Hey class, so today I'm going to be making two videos, hopefully pretty short, but enough to cover the last two things that we covered in class. The first thing that I'm going to go over again is this idea of vertical shifting. Um, so the vertical shift is denoted by a D in these equations, and all this D does is bring your sine or cosine function up or down along the y-axis. So you can think about it like, the difference between y equals x and the difference between y equals x plus 4 is just that y equals x is just right there, whereas y equals x plus 4 is shifted up 4 on the y-axis. It's the same exact shape, it's just moved upwards 4, and that's all that this vertical shift does to our sine and cosine functions. It leaves the shape the same. All it does is displace those y values up or down based on how big or small that factor d is. And the good thing about d is that the shift is obvious when you look at the equation. So if d is greater than 0, then d is shifts your y values up. And if d is negative, then it shifts it d units down. So it's not like c over b, where you had this minus sign right here. That made it a little bit more complicated. D, whatever the sign of it is, that's going to tell you whether you're moving up or down. So the first thing that we want to do when we're solving these is rewrite it in the typical way that we do. And since this rewriting has nothing to do with our vertical shift, we're actually going to have a lot of the same steps. The main thing that is going to change is this range in step 2. So now our amplitude, or our range, is not simply going to be a positive and negative amplitude. It's going to be the negative amplitude plus d and the positive amplitude plus d. And again, this goes back to the only thing the d is doing is changing the y values up or down. So we'll, go over that concretely when we cover the example below. So we still have the phase shift being c over b. The period is still 2 pi over b. We still have the same x coordinates. And now, obviously, the y coordinates change because of our change in range. So the way we're going to find our y coordinates is we take our original ones. So for example, cosine was 0, 1. And now we multiply this by our a factor and add d to that. So we're multiplying our y's by a and adding the factor d to it in order to obtain them. So let's just get into a concrete example so that way we can really talk about this. Give me 1 second. Okay, sorry about that. I found my example. So here we want to sketch this graph. Okay, and before I start our typical process, I just want to highlight that this -1 is going to be our vertical shift. So we're shifting 1 unit downwards. Okay, now we want to solve the rest of it as we did before. So I'm going to do a rewriting step where what I'm going to do is factor out that 2 in front of our x. So we take the 2 out, which means we have to divide 2x by 2, leaving just x, and we divide pi by 2 as well, leaving us pi over 2. So that's all we had to do in this step in order to rewrite our function in the way that we would like it to appear. So here we have an amplitude of 3. This right here is going to give us our amplitude of 3. And our range is going to be -3 minus 1, comma, +3 minus 1. So all I did was use the formula that I wrote above, -a plus d, and absolute value a plus d. So just highlight that. And that gives us a range of -4, 2. So our minimum is going to be -4 and our maximum is 2. So we have a positive sine function. Actually, hold on. Getting ahead of myself. So the first thing we want to talk about is the b over c, or c over b rather, which is going to give us our first x coordinate. It's a positive pi over 2. Just the opposite of what we see right here. And our period for this graph is going to be 2 pi divided by 2. So our period is just pi. All right, so typically for a positive sine graph, the first point is going to be 0, 0. Our second one is going to be pi over 2, 1. Then we have pi, 0, 3 pi over 2, -1, and 2 pi, 0. Okay, this is our typical sine function, quarter points. However, now we have a vertical shift, a phase shift, and a different amplitude. So we've changed all of the x's and y's of this sine function. So now instead of starting at 0, we're going to start at pi over 2. The next thing, our y, the starting value, is going to be at our vertical shift. It's -1. So remember, as I said in step 6, right, we're multiplying by a and adding d. So here, when we have our original y value be 0, we multiply it by a, which gives us 0, and then we add d. So we just get d. Our second point, we're going to add a fourth of this period. So we're going to add a pi over 4 to our c over b, which is going to give us 3 pi over 4 for our x coordinate. And then for our y, we're going to multiply by a and add d. So we get 3 minus 2, which gives us our maximum of 2. For the third point, we're going to add another pi over 4, which gives us pi. Our 0 is going to be -1, or phase shift again. Then for our fourth point, we add another pi over 4, which gives us 5 pi over 4. And then we multiply this by a and subtract d to get -4. This right here, our last point, is going to be adding another pi over 4, which is going to give us 6 pi over 4, but that simplifies to 3 pi over 2. And again, our zeros are just going to change to d. So now that we have all the quarter points, we could easily sketch that graph. I can kind of do a miniature version here. So we start at -1, right? Yeah, so we'd start somewhere like here. Where this height would be 2. And this would be -4. This line would be -1. And that's what our graph would pretty much look like. Okay. So for our next example, we have this function right here. Now, I'm going to walk through the rewriting stage of this example, and then once I rewrite it, I want you to try to solve it on your own. So we have this 4 in front of a cosine, and I said before that rewriting isn't going to involve in d. this is the only time when rewriting our function is going to involve changing something with d. And all we do is just swap these. So instead of having 4 minus cosine, we're going to have negative cosine plus 4. So we have negative cosine of minus 2x plus pi plus 4. So all we did was flip their order. Nothing too crazy. And then we want to factor out this negative 2. So again, minus cosine, negative 2x. We divide this pi by negative 2, which gives us negative pi over 2. We still have plus 4. So remember, cosine is even. So that means that negative just becomes a positive. So we have 2x minus pi over 2. Okay. So this is the last stage of the rewriting process. It looks how we want it to look. And now I'm going to pause my recording and give you a second to try to figure this out. And then in just a second, I'll tell you the answer. So go ahead and try to pause the video and solve it yourself, and then I'll talk about the answer. Okay, so here we have our final solution. These new coordinates are what you should have gotten for this function. The original quarter points are for a positive cosine function, and here we have the 5 quarter points for this function. So things that are highlighted was that the period and c over b did not change. So our x coordinates are the same ones from our last example. However, this range has changed pretty significantly. Now we don't have any negative y coordinates, and that's because this vertical shift is so high compared to what the amplitude is, which is just 1 in this case. So we have all positive y coordinates, and just again to emphasize where these came from, here I just took the initial y coordinate of 1 and multiplied that by a, and then added d to that result. And in this case, that meant taking 1, multiplying it by a negative 1, and then adding 4 to it, which negative 1 plus 4 just gives us a 3. Okay. So hopefully that helped out. The last thing that I really could talk about is just, let me actually just open the PDF, because I don't think it's going to be in the Word document. Yeah. So the only thing left to talk about is the getting a graph from, getting the function from the graph. And here, I guess I can pause the video and maybe try to explain this a little bit more in depth. Yeah, that would be a mess. So maybe I can do that next video. For now, let's just stop it here. Okay.